Okay, so now that we finally have all the background stuff on ultrasound, let's talk about how do we actually apply this. So first thing to consider, we've already talked about this, is your treatment area. So remember that ultrasound can really only increase our tissue temperatures when the treatment area is held to about 2 to 3 times the ERA. Okay, so also remember that the ERA is different than the transducer head. So the ERA is usually smaller. Some research shows that it's usually at least about half the size of the transducer head. So you got to really pay attention, look on your machine what the actual ERA is, and then do, again, between 2 to 3 times of that. So ideally closer to 2. So for larger areas, you have to use multiple treatment zones. So you can actually sketch that out and draw on the person. Okay, so here's my 10 centimeter area. I'm going to do this treatment first. Then I'll set up a treatment and do this next 10 centimeter area. If we're getting any bigger than that, then just time-wise, it doesn't seem as effective. There's actually diathermy, which we'll talk about in our next chapters. That's an option. We don't have it at Gustavus, but it's an option out there in healthcare settings. Treatment areas for non-thermal treatments can be usually slightly larger because we're not trying to overwhelm the body's natural desire to disperse that heat, so we don't have to kind of keep adding heat just to that area. So it can be a little bit wider and larger of a treatment area because we're just trying to stimulate those cells. But we definitely don't want to get so large that we're not getting the cavitation and the microstreaming directly where we want it. So there's less definitive guidelines for that, but you want to keep that in mind. On to the coupling methods. So like I said, you have to have gel or something, water, to apply the ultrasound to, because the idea is to try to minimize the air and maximize the contact with the tissue. So remember that the ultrasound head will have the largest energy reflection at that air ultrasound head or the air tissue interface. Okay, so we need that medium to transmit the energy from the transducer to the tissue. The best non-reflective medium that we have is actually water, and specifically distilled water or degassed water. That only reflects about 0.2% of energy. But most commonly what we probably use is gel, an ultrasound gel that's specifically made. It has certain percentage of sodium and other salts in it. It's specifically made for ultrasound. The other thing to kind of keep in mind is that there's other things that we can use. You want to go back and look at that chart that I had in the phonophoresis chapter or the phonophoresis video of how when you change the medium, how much transmission of the ultrasound you actually get. So some other ones that are typically done are mineral oil, glycerin, sometimes analgesic creams like Flexol or Biofreeze or things like that. And sometimes those are just those or they're mixed with a gel. But anytime we do that, we're definitely decreasing the amount of transmission that we have. So you need to be aware of that. And you'll do, again, a experiment and activity that teaches you some different things about the different coupling methods that you could do. So you have to use the coupling methods that's best for your transducer. So you want to usually use one that's meant specifically for ultrasound and sometimes even specifically for your type of machine. And we do have direct versus indirect. So direct is when we're doing ultrasound directly to the skin. So again, with gel in place. So for direct application technique, we apply gel liberally on the skin. Okay, we don't want any large air bubbles because air bubbles will then reflect our ultrasound energy. Air bubbles will also cling to hair. So again, shaving the area might be important if they're hairy. The effectiveness of the ultrasound transmission gel is decreased if the body is hairy or if it's irregularly shaped, right? Because that's going to change your contact with the ultrasound head, which is one of our biggest things. When we are doing ultrasound, we need the head to always be in contact with the coupling medium and then to the tissue. So as we turn on our ultrasound and do all of our settings, we always want the ultrasound on the body and moving around. So, because we always keep the ultrasound head moving and we want it in contact. We don't ever want to lift up the ultrasound head to the skin or to the air, so away from the skin into the air, because all that energy is then going to reflect, and some of that can get reflected back into the transducer, and that amount of energy could potentially disrupt the crystal and break the crystal, and then your machine is broken. So, we always talk about the crystal like it's some, thing you have to whisper and talk about, but you do want to protect the crystal. So we always have our ultrasound head down in contact with the skin as we're turning it up, and when we turn it on, we're always in contact. So again, if our patient tells us that it's feeling too warm, we want to instruct them not to pull away, okay, just to tell us, and we'll actually move the ultrasound to maybe a bigger, fattier, deeper area for a little bit and let it cool down, and then come back and speed up our ultrasound treatment, because that's a sign, right, that they're getting a hot spot. So we kind of speed up our speed a little bit, or we adjust our intensity down. But we don't want them just to pull away, because we don't ever want the head of the ultrasound to get exposed to the air. Okay, really important. Doubly important. Pay attention the most. Don't break the crystal. So that direct application, we want firm, constant pressure. And again, that's going to be really hard if it's over like the ankle or the hand, where we have a lot of irregular shapes. We can't keep the sound head in complete contact. And so we run the risk of us, one, not getting all the energy into the tissue that we think we're getting, so we're not going to get the effects we want, but two, that we potentially could damage the ultrasound head and the crystal. So firm, constant pressure, really good contact. Try to be at a 90-degree angle, our cosine law, as much as possible, and move the head kind of slowly along the area. So these are, so that was the direct method, which we see here. We also have indirect methods where we can use, this is using a gel pad, but you could also, so this they sell, it's a solid gel that you can put over the area that you can reuse, so you don't go through the gel as much. But you got to also think that you're now increasing your distance, right, from our energy source to the tissues. So the thickness of your gel pad is important to understand. Some people also will like fill a balloon or a condom or something like that with gel, and then you put gel over the top of it too, and you use that, because then that can form over bony areas, over the ankle, over the hand. So that's another option, or you could even fill that with water. Just know that you're going to have some reflection at the balloon surface, so the rubber or whatever the balloon is made out of, or the silicone or whatever you might be using. And so it's usually not as effective as the direct transmission. So you fill the bladder with the ultrasound gel, get all the air bubbles and air pockets out of it. So you'd have to make sure that you don't have any air bubbles in there. And then you put gel down, you put the bladder down, and then you put gel on top. Same with the pads, the commercial pads, which are usually better. We don't get that reflection off the material that the bladder is made out of. We usually put some ultrasound gel on the top and on the bottom of the pad itself too, to just help with friction, so that the ultrasound gel really can, helps the ultrasound head keep moving around. Other thing we can do is underwater ultrasound, just like we had underwater stim, okay? So in this case, the water again becomes our medium. Ideally, we would use what they call degassed water, which you can actually boil water for about 35 to 45 minutes and then store it in an airtight container. And so it doesn't have to be hot, but you store it then, and you can use that. So that's degassed, or you can use distilled. But again, you'd want to put your ultrasound head in the water. You want to be about an inch away from the surface that you're trying to treat. It's less effective as direct, but you want to make sure you're at a 90-degree angle. Remember, think of our cosine law. So you want to be parallel with the skin's surface. Ideally, your hand is not also in the water, because that can divert some of the energy. So ideally, you hold your hand out of the water. If you aren't using the degassed or the distilled water, you'll usually have to turn up your intensity by an extra 0.5 watts per centimeter squared to kind of account for the fact that we're going to disperse a lot of this energy around. So you just have to add that to your treatment time. But you submerge the body in, and then ideally you're also using a ceramic or a metal tub. This one shows a plastic tub, so you can do it in that, but you get a little more reflection with the plastic. So again, if any bubbles form, so which we'd expect to see with the cavitation. We can just take a tongue depressor and kind of wipe those away from either the surface of the skin or the surface of the ultrasound head, um, because we don't want those bubbles. We don't want the ultrasound to hit the bubbles and then get reflected off. We want it all to go into the tissue if possible.